Hello, my name is Shafiz bin Rosli, and today I will explaining the role of earthwork in construction project. So before that, let me explain on what is earthwork. Earthwork is the early process for the construction project which form a foundation for all structural and infrastructure components. Earthwork also includes essential tasks such as excavation, cutting and filling, backfilling, soil compaction, and site preparation. These operations are fundamental in ensuring the project meets the engineering specification while providing a level, stable base that can support long-term structural integrity. Without a proper earthwork, even the most sophisticated design may fail due to foundational weakness. So, this presentation will be focused on two major government infrastructure project in Bintulu, Sarawak. The first one is Projek Pembinaan Sekolah Kebangsaan SK Samalaju dan cadangan naik taraf Balai Bomba dan Kuartus Bintulu. Both projects are rely heavily on extensive earthwork as a preliminary steps before structural construction begins. These developments are not only vital in improving public amenities, but are also part of broader national objective that prioritize education, safety, and balanced regional development. Next, I will be explaining the project overview and parties involved in both projects. In the Balai Bomba and Kuartus project, the earthwork involves site clearing, grading, and preparing a strong foundation for the fire station and residential quarters. Given the functional demands of this facility, such as the need to support heavy emergency vehicle and equipment, the ground must be truly compact and level to ensure durability and safety. The reliability of this infrastructure is critical for emergency responsiveness in a rapidly growing town like Bintulu. Similarly, in the SK Samalaju project, earthwork play a crucial role in preparing a safe and stable foundation for several school facilities. These include academic blocks, dormitories, administrative office, science lab, and a library. As the project is located near the industrial active Samalaju Industrial Park, proper soil treatment, environmental regulation compliance, and effective drainage system are crucial. The school serve the educational needs of the children in the community, particularly those whose parents work in nearby industry. For the project background, the SK Samalaju project is driven by the Ministry of Education Malaysia (MOE) to accommodate the increasing demand for quality education due to Samalaju rapid industrial growth. The school is designed to act as a one-stop center, offering comprehensive learning facility that will bridge educational gaps in the area. On the other hand, the Balai Bomba project is managed by the Ministry of Housing and Local Government (KPKT) and aims to enhance emergency response service for Bintulu and its surrounding. The project involved the construction of a modern fire station equipped with truck bays, training rooms, workspace, and living quarters for fire personnel. This project ensures that emergency services are readily available and can respond quickly to disasters in the expanding industrial and residential zone. As you can see on the table, these are the parties involved in the project. Parties involved in the both project involve a comprehensive team of professionals who contribute to different stages of design and construction. These parties are selected based on their qualification, experience, and ability to meet the specific needs of each project. For example, SK Samalaju client is Ministry of Education Malaysia (MOE), and for the Balai Bomba, Ministry of Housing and Local Government Malaysia (KPKT). The clients are the project owners responsible for initiating and funding the project. They ensure the development aligns with public and national priorities from planning to completion. For the architect, they were in charge of design, building design and space planning, ensuring the functionality, safety and aesthetic of the structure. For civil and structural engineers, they were responsible for technical integrity of the structures, particularly the foundation and load-bearing systems. They conduct soil tests and design structural elements like slab and columns. And for the mechanical and electrical engineer, these specialists handle internal systems such as electrical wiring, fire protection, lighting and plumbing to ensuring building functionality and safety. For quantity surveyors, they manage to budgeting and contractual aspect for the project. They prepare cost estimates, evaluate tenders, and monitor financial performance to keep the project within budget. And for the last one is the contractors. Contractors execute the actual construction, coordinating manpower, materials, and equipment to deliver the project on schedule and in compliance with all specifications. Since Earthwork is one of the most vital phases in a building project, it includes a series of essential operations such as site clearing, excavation, backfilling, leveling, and soil compaction. This process forms the foundation of all structural elements, ensuring that the building has a stable and level base. However, the tools and equipment selected for Earthwork depend heavily on specific site conditions such as terrain, soil composition, access limitation, and the scale of the project. For example, the SK Samalaju site is located near the Samalaju Industrial Park, an area characterized by relatively level ground, partial site clearance, and clayey sandy soil. As a result, the use of large-scale machinery capable of handling wide area excavation, compaction, and leveling efficiently. The goal here was to prepare a platform suitable for multiple school buildings and facilities such as classroom, administrative office, hostel, and science lab. The tools and equipment used for this project is bulldozer, which were deployed in the initial phase to clear the site of vegetation and topsoil. Next, excavators were vital for trenching tasks, especially for deeper cuts needed for structural foundation. Their ability to operate effectively on clayey soil and adapt to uneven ground make them indispensable for this project. Next, dump truck. Once the soil was excavated, dump trucks were used to transport fill materials across the site. These vehicles were chosen for their ability to carry large volumes and move quickly across the level terrain. Next is motor grader plays a key role in shaping and leveling the subbase, especially for internal roadways and the platform. This ensured that the base layer met engineering tolerance before final construction began. And next is plate compactor and tamping rammer. In narrower trenches, plate compactors and tramping rammers were used for localized compaction. This machine ensured that smaller structural elements such as beam and footings had adequate soil support. Next is vibratory roller. Vibratory rollers were used to compact broader surface such as base for academic blocks and dormitories. This roller helps achieve uniform compaction over large area, critical for supporting multi-story structure. For Balai Bomba Bitulu project, the Balai Bomba Bitulu project was developed in a denser, semi-urban area. The site featured more compact layout, with limited space for maneuvering large machines. Nonetheless, Earthwork remained crucial for preparing site ground for vehicle bays, training areas, residential quarters, and access roads, all of which must support the weight of constant activity of fire truck and emergency vehicles. The equipment that been used for this project is mini excavator. Due to the tighter working condition, mini excavator were used instead of standard large machine. Their smaller frame and efficient fuel usage made them suitable for confined excavation work such as utility trenches and drainage line. Next is skid steer loader. Skid steer loader were ideal for light material handling and backfilling operation in the limited work zone. Their tight turning and radius maneuverability were assets in small or obstruct area. To achieve deep compaction in cohesive clay area, especially the fire truck access road, ship foods roller were likely used, and these rollers are specifically designed to compact deeper layers of cohesive soil by applying pressure through point feet. Next is smooth drum roller. Once deep compaction was complete, smooth drum roller were employed for surface level compaction. This provides a stable and even surface to finish suitable for heavy vehicle movement and
Hi, my name is Muhammad Nazif bin Muhammad Zakaria, and I will be explaining the type of soils and its properties. Firstly, in SK Samalaju, based on the geotechnical studies in the Samalaju area, it shows that the site mostly comprises of tropical residual soils. These soils include alluvial silty clay, which is very common in the low-lying areas where the soils are plastic, moderately to highly compressible, and it has the plasticity index values between 20% to 30%. The moisture content was almost excessive, where it ranged from 35% to 40%. This is indicating that the soil still holds a lot of water, which eventually will cause a pressure buildup, especially during the rainy seasons. Next, the Balai Bomba JBPM Bintulu. It has peat and organic clay. Peat and organic clay have extremely high water content, which typically ranges from 100% to as high as 2000%, and the organic content exceeding 55%, which results in the shear strength at a low level with high compressibility. Compressed peat poses a huge threat as it can affect the soil strength and the stability of it, potentially making it dangerous to use. And lastly, the load bearing capacity of the soil is very limited as well due to the soil conditions and making it very unsafe without any treatment. Next, I'll be explaining the scope and magnitude of earthwork operations. For SK Samalaju, the process began with the removal of vegetation and surface debris, followed by site leveling to achieve level building platforms. Due to the site's naturally uneven terrain, significant cutting and filling were required to create stable to construct these structures. Next, the topsoil removal and storage. The fertile topsoil was stripped and stockpiled for reuse in landscaping and turfing, thus reducing the costs and benefits the environment itself. Next, the chemical treatment or stabilizers were used, such as lime and cement, to reduce the plasticity and improve the strength over time. And lastly, for mitigating the erosion and the drainage, due to the silty clay's low permeability, a comprehensive and effective drainage system was introduced. Next, the Bomba JBPM Bintulu. It started with the pit excavation and removal. The pit layers were fully excavated and transported to a designated spoil locations. Then the excavated voids were backfilled and with compacted sand and gravel in layers. Next, the temporary loading was used to speed up the settlement in the remaining compressible layers. Vertical prefabricated drains, or also known as PVDs, help release the excess groundwater. minimizing long-term settlement, where it is particularly important for the structural loads of the fire station's vehicle base for the preloading. For the drainage infrastructure, a combination of open concrete drains and underground pipes were redirected surface and groundwater to reduce pressure below foundations, which is essential in a high rainfall area and low lying setting. And lastly, the final granular fill layer was compacted to form the base for the foundations and the pavements.
Assalamualaikum warahmatullahi wabarakatuh and greetings. My name is Shahwarizmi bin Bujang Sali. I will explaining and presenting the excavations, grading, backfilling and compaction, the technique used. Alright, so for both of the project which is SK Samaraju and JPBM Bintulu for excavation, for the first one is they use hydraulic excavators, which is commonly used in the construction nowadays. All right. Next one is both of them have soft silty clay, which is both of the project. They are nearly at the same location, which is at Bintulu. So they need to excavate section by section. All right. Next one is it is for purpose for spoil reuse for backfill. Okay. How about backfilling? SK Samalaju, they layered the fill less than 300 millimeter, compacted with the rollers or plate. So it is important for the granular material for SK Samalaju. How about JPB MB dulu? It is a slow backfill, smaller tools needed because JPB MB dulu is smaller than SK Samalaju. Alright, next one is waterproofing. JPBMB dulu, they need waterproofing before fill because we know JPBMB dulu is nearest to the city. While SK Samalaju, its construction is open area. Next one is compaction. For both sides, they have plate compactors and rollers send the contest for the density and moisture based on the project. Alright, so the summary of this section, the technique follows JKR standards as always. For SK Samaraju, it is open space, so they're using standard methods. How about JPB and Bitulu? It is a tight site which is small, need precision tools compared to SK Samaraju, and need to stage the work by schedule.
Hi, hi. My name is Kevin Joshua, and today I'm going to present about the problems faced during earthworks construction and what are the solutions to overcome it. So the first one is soft ground and water retention. This problem happens due to the silty clay and marine deposits that have caused poor drainage to the site. This is due to heavy rainfall that causes standing water and disrupts machinery, which increase the risk of settlement. So the solution for this problem is there are temporary open drains and some pumps were installed, and also granular fill and crusher run were added to create a firm working platform. The second one is inconsistent backfilling and settlement risk. This happens due to improper backfilling techniques that can cause concerns of uneven compaction. This also can cause long-term differential settlement. The solution for this problem is the fill was placed in less than 300 millimeter layers, and also moisture content was regulated by site teams using site water tankers and airing methods. Third, material handling and access constraints. For this project, the space is limited due to for limited has limited space due to material stockpiles and machinery movement. These have led to delays in field delivery and coordination of excavation casting. Mm. So the solution for this is use smaller trucks in order to access the site in stages. Second, material deliveries were scheduled outside peak hours to avoid road congestion. And lastly, temporary laydown areas and sequencing plan had improved site logistics. Next, I'm going to talk about the recommendations and improvements. So the first one is early soil investigation and training. Geotechnical investigations team should be conducted before earthwork begins. This includes borehole drilling, soil classification, groundwater table identification, and lab tests. The second one is use of standardized earthworks method statements. Having approved method statements ensure consistency in earthworks execution. This guide contractors in excavation depth, backfill layers, thickness, compaction standards, and testing frequencies. This also to avoid confusion and improve communication between parties. Third one is improve machinery scheduling and access planning. Proper scheduling of machinery helps avoid site congestions, ideal time, and conflicts within trades. A staggered delivery, defined machinery path, and designated unloading zones can help in increased efficiency and safety. The fourth one is digital tools for site management and monitoring. Utilizing digital technologies such as GPS guided excavation tools, drone based site mapping, and digital process tracking helps in precise earthworks measurement and in real time updates. These tools assist in identifying potential delays or quality issues at an early stage. So, next is environmental and safety awareness training. Training site workers in safety protocols, erosion control, and equipment handling and environmental management ensures that the earthworks are carried out without endangering lives. It also ensures compliance with government regulators and project specific environmental standards. So the last recommendation is inclusion of value engineering in earthworks. Applying value engineering during the design stage allows the team to evaluate alternative solutions such as adjusting platform levels, using recycled fill materials, and reducing haul distances. This also can improve construction method while also reducing unnecessary costs. That's all from me. Thank you.
Alright, moving on to the next one, I will explaining on the comparative similarities and differences. Alright, there are 10 aspects that we have analyzed for the both of project SK Samalaju and JPBM Bitulu. For the first one is project environment, I will focusing on remarks and some of description for both of the project. Alright, for the first one is project environment. Both of the project have different setting in fluid logistic based on the schedule. Next one is soil condition, which is they both of them have different soil behavior, which is nearly same because they have silty clay, but JPPM Bintulu have more stable compared to SK Samalaju. Next one is foundation type. For SK Samalaju, they're using spread footing, while JPM Bintulu, they're using deeper excavation type, which is piling. So they adjusted to soil bearing capacity based on the bearing capacity. Next one is building height. So both of the project we take surau and quarters. So SK Samalaju 1 story surau and 4 story quarters, while JBBM Tulu 1 story surau and 7 story quarters. So it's for the remarks it is increased complexity based on the height of the building. So excavation depth, it is deeper cut in urban site. Machinery usage, access limitation in Bintulu site, which is the JBBM Bintulu. For drainage consideration, both follow proper drainage protocols. So because drainage doesn't have any different requirement because both of the project are government project. Alright, material handling, Bintulu required tighter scheduling because JBB and Bintulu have nearest to the city while SK Samalaju has construction in open area. Alright, for material handling, Bintulu required tighter scheduling and safety control due to urban traffic and height risk. So JPMB dulu need to be stricter compared to SK Samalaju. And the last one is estimated Earthwork cost. So based on analysis, for SK Samalaju, quarters and surround have 605,000 and 180,000, and JPBM dulu 650,000 and 200,000. Different cost level based on the complexity. Yeah. All right, how about the effectiveness and efficiency comparison? So for the first one is I have 1, 2, 3, 4, 5, 6, 7. There are 7 criteria that we have analyzed. So for the first one is site access. For SKS Malaju, it open unrestricted because we have explaining that SKS Malaju, they construct in open area where the site area doesn't have any existing building. So next one, JPB Pintudo, it is construct on the urban area, so more restricted for site access. Next one is equipment utilization. SK Samalaju, they have high and continuous. while JPMB Dulu, it adjusted to space limitation based on the site access factor. Next one is material handling. So for SK Semaraju, they use bulk delivery stockpile on site, while JPPM Bintulu, they have phase delivery limited laydown area. Also, it affected by the where the location of the construction. So, how about time management? SK Samaraju, they highly flexible and less constrained compared to JPPM Bintulu, that are tightly managed due to constraint the site access and the how the construction locate. Okay, how about safety control? Both of them using JKR DOSH compliance. Need to be compliance, need to be followed. So for SKS Malaju, it is easier for the layout, and JPBMB dulu, they have to need strict enforcement. How about result effectiveness? They have high but better than JPBMB dulu, while the JPBMB dulu itself, they have high result effectiveness but have more risk compared to SK Samaraju. So how about operational efficiency? Bothly good, but JPMB dulu moderately good. Alright, for the next one is this is the sample of the table SK Samalaju quarters for the breakdown cost for the earthwork. Alright, there are 1, 2, 3, 4, 5. There are 5 items that we have take from the BQ. So there are pad footing excavation, ground beam, and apron slab, which is the need excavating that related to earthwork. Also filling greater than 250 millimeter thick, filling after the excavation, hardcore to pad footing, ram and ground slab. Overall, for the SK Samaraji quarters, 43,388 ringgit 90 cent. Alright, next one, I will presenting about the detailed cost analysis part 2, which is JPB and Bintulu quarters. So the part 1 is for SK Samalaju, and this is one is I will presenting about the JPB and Bintulu quarters. Alright, so for JPB and Bintulu quarters, there are 1, 2, 3, 4, 5, 6, 7, 8 items. So this one is the reduced level excavation, clean stone fill, bed foundation excavation, which is they have various sizes, rock excavation allowing 10% for provisional item, spoil disposal of site, backfilling with excavated material, beam trench excavation, and anti-termite treatment. So not all of the item are same with the cost analysis part 1, which is for the SK Samalaju, because they only provide the item. Some of them exist, some of them are not exist. Although it is completed, but the BQ are not completely shared. So for the amount that we have analyzed, this JPM dulu have around 38,756 and 80 cent. All right, moving on to the conclusion. So, the project review is SK Samaraju and also JPBM. Both of them are located at Bintulu. So, we choose Surau and Quarters for this project because both of them have nearly similar characteristics but different in terms of the site impact challenges and the recommendation for this conclusion. All right, so the site impact for the SK Samanaju is, yeah, we know it is an open site that enable efficient work compared to JPBM Dulu. They're located at urban site that require adaptive strategies. So the main cost item is, example, granular fill, hardcore blending concrete. Also, the important part is the excavation itself. Alright, the challenges and the solution, there are three. First one is soft ground, limited access, and settlement risk. Soft ground, they need to do control compaction. Both of the location, they doesn't have any too much difference, so they need to control efficiently for the compaction to make the construction construct smoothly. How about the limited access? For SK Semalaju, open site, so they need to face scheduling always strict. For the JPBM dulu, because they are in urban site, they need strict scheduling. Settlement risk, no different, so they need to, yeah, subsoil drainage to be constructed. How about the recommendation? There are three. First one is early soil testing. Second one is standardized method segment. And the third one is use of the digital site monitoring. So what is the key takeaway for this assignment? It is an effective earthwork, ensures safety, structural stability, and cost control. It is critical for the project success. So I think that's all from us. Thank you.